All right, in this video, we're going to look at a special type of solution where we have gas solutes in liquid solvents. And I like to kind of highlight this difference because gases dissolved in liquids act a little bit differently than solids dissolved in liquids. And I'm just going to use, soda as an example here in the beginning. The thing that gives it its carbonation at that fizz is carbon dioxide gas dissolved in water. And here's one of the big differences between gases and solids. Remember that the solubility of a solid goes up as temperature increases. But the solubility of a gas decreases as temperature increases. And you've had experience with this. If you open up a soda and then you let it sit sit out on the table for a, extended period of time, you come back and taste it. What's it taste like? It's gone flat, or its carbonation has like gone down a whole lot. And the reason for that is that as you increase the temperature, what are you doing to those gas molecules if you increase the temperature? You're giving them more energy. So gases have more energy with an increased temperature and therefore can leave a whole lot easier. Easier is not a very scientific description, but they have a lot more energy to come out of solution. It's the same thing that occurs, for example, with a lake or a body of water. If you increase the temperature of that water, that's going to cause the solubility of oxygen within that lake to become less, and more oxygen will leave. And a lot of times that leads to a die-off of a lot of the aquatic life that's in there because they don't have access to the same amount of oxygen when the temperature increases. So we've talked about temperature. Let's talk a little bit about pressure, the effect of pressure on a gas. We don't care about pressure when it comes to solid solutes because there's no effect. But in general, the solubility of a gas increases as the partial pressure of that gas increases. And I want to highlight that it's got to be the same gas. So for example, let's imagine a closed can of soda. So here's my great drawing of a soda can. And I'll leave a little bit of airspace here because there's a little bit of carbon dioxide in the empty space. And there's a lot of carbon dioxide inside the soda. Now, as soon as I open up that can, you pop it open, you hear that kind of characteristic like click and hiss. And when you are opening that can, what you are doing is you're decreasing the partial pressure of CO2 above the liquid. And so now the soda is open and CO2 escapes. The partial pressure has decreased, and in fact, the CO2 that's in solution, there's going to be a lot less of it because it's going to start to come out since the partial pressure has decreased. Now, I can add more CO2 and thereby increasing the partial pressure of CO2 So let's say somehow to that closed can of soda, I add a little bit more CO2 above here, increasing the partial pressure, and that's going to increase the amount of CO2 that's in the soda. And one other thing I want to emphasize that the solubility of CO2 only changes with the change in pressure of CO2. I can add another gas to this. Let's say I add some oxygen. So somehow I add oxygen to this closed can of soda. It doesn't change the amount of CO2 that's in that airspace above the liquid. And the amount of CO2 inside doesn't change. Even if I add a whole bunch of oxygen in there. So the solubility is only dependent on the partial pressure of CO2, not if I add any other gas. And in the following problems, we're going to do some examples of demonstrating this how we can like quantify the solubility of a gas in a liquid in our next video.